So we have a tennis player hits a ball 2 meters above the ground. Ball leaves his racket with a speed of 17 meters per second at an angle of 4.5 degrees above the horizontal. The horizontal distance to the net is 7 meters, and the net is 1 meter high. So for this one, I like to make value 0 when I can, so I decided to raise the horizontal axis and make the net height actually 0. So if the net was here, its height would be 0, and I lowered this. Instead of 2 meters high, I made it 1 meter high. And he launches it, or he or she launches it at 17 meters per second, an angle of 4.5 degrees. Draw in our vector components. And we need to know. We want to know if this ball's going to clear the net. I guess it's more of a slider arc, I guess. So we need to know. What do we not? We don't know how long it's going to take, so we need to know. We need to calculate time, and we need to calculate what its final position is going to be, which will be xf. So we'll just go down the OFART chart and calculate our initial velocity in the x direction, or horizontal direction, which I got to be 16.9, and did that with this equation: 17 cosine 4.5, 16.9, and the y velocity, velocity in the y direction, was to be 1.33 meters per second. And this 16.9 for our final velocity in the x direction will remain constant. And then our acceleration is always 0, and that for the x direction. And for this projectile equation, it's negative 9.8 meters per second squared. And I like to split this up just to keep these values separate. And we'll be calculating xf, our final position, and our final y position will be the height of the net, which we made 0. And then our initial position for xf is 0, and don't need to worry about that really, but we know that the time will be equal for both occasions, and so we should calculate time. So for the time, I used this equation using the y variables, the y direction equation. So we know that yf position is 0, y initial was 1, our initial velocity is 1.33, and acceleration was negative 9.8, and I use a graphing calculator to find that time when this ball travels and reaches the same height as the net. The time will be 0.608 seconds. And we need to know if it clears net still. So we need to use time and plug that into our XF equation. We can use XF or X final equals X naught plus Vx, our velocity in the x direction, times time. So we can use our same velocity for this equation. In this equation we can use 16.9 in this variable here because it's constant in both cases. If it wasn't constant, we wouldn't be able to use this equation. So plugging everything in, x final, and then x initial is, where is that? That is, x initial is 0. And then velocity, x direction, or horizontal direction, 16.9 times our time, 0.608, and we get xf equals 10.3 meters. So the ball will fly it will reach the height of the net, right? 10.3 meters. So it definitely clears the net. We know that. So it clears the net, and the second part of the question was we want to know by how much does the ball clear the net. So when it's traveling along this arc and it lands, what's this height here? How much does it clear the net? So that means we'll need, so we want to find the position of the tennis ball above the net. So we need a new value for t. So we're going to find t2, and then we're going to use 7 meters for the value of xf, because that will be its position when it's above the net. So we'll use the same equations, except we'll do it backwards this time. So we'll plug our 7 meters in here. X is still 0, and Vx will still be 16.9, and then our new time, and then we'll be able to calculate t. And then we'll plug it into our new t value into here, another y equation. Then we'll be able to find the height of the ball after traveling 7 meters horizontally. So we calculate our next t value, which will be t2. So everything's the same. I made another column. I don't think you necessarily need to, but it helped me get through it, and I corrected some mistakes doing it, so it might be helpful. Velocity still the same. And 0 acceleration, we don't really need that. 7 meters, we'll use that right here. XF, 7 meters. And then our initial position, 0. And 16.9 is the velocity. And we calculate for t, we get 0.414 as our time 2. And then we'll plug that into our y equation so we can get to its position, its height above the net. And so YF is what we want to find. Why not? Why not is 1. It's 1 meter right here. So 1. And then our velocity will be 1.33. We don't know this. And I still have negative 9.8 for acceleration. Time is 0.414. And that should be all we need. And I calculated and I got 0.71. So it will be 0.71 meters above the net. So for the assessment, even though the angle is slight, like 4.5 degrees is a pretty small angle, in 1 second the ball would travel about 56 feet, because 17 meters per second is about 56 feet per second, and half of that is 28 feet. In a half a second it travels 28 feet. And the distance to the net is 23 feet. So it seems reasonable that the ball will clear the net